A new study has confirmed that the Earth's inner core is solid, but probably a lot softer than previously thought. The findings, reported in the journal Science, provide researchers with a new glimpse into planet Earth's formation and evolution. The discovery is based on the detection of J-waves or shear waves following earthquake activity. These waves can only travel through solid objects. The study's lead author, Associate Professor Hrvoje Kulčić, together with Anson Pham, both from the Australian National University, used a correlation wavefield method to examine similarities between the signals at two receivers after a major earthquake, rather than focusing on direct wave arrivals. As well as confirming that the inner core is solid, the authors also found that it's softer than previously thought, with the nickel ion having elastic properties similar to gold and platinum. Inner core shear waves are so tiny and feeble they can't be observed directly. In fact, detecting them has been considered somewhat of a holy grail of global seismology ever since scientists first predicted the inner core was solid back in the 1930s and 40s. So the authors came up with a rather creative approach. They firstly ignored all the big seismology readings coming through during and immediately after an earthquake. Instead, they searched for fainter signatures, coming through about 3 to 10 hours after a large earthquake had occurred. The authors used a global network of seismic stations, looking at every single receiver pair and every single large earthquake, in order to measure or cross-correlate similarities between the seismograms. It was from those similarities that they constructed a global correlogram, a sort of fingerprint of the Earth.
I think that this research using the correlation wave field, which is a new paradigm in seismology, in global seismology in particular, demonstrated the potential of this method, and I think that it opens up a way for new discoveries about the internal structure of our planet.
The results were then used to demonstrate the existence of J-waves and infer the shear wave speed in the inner core. Kulčić says understanding the Earth's inner core has direct consequences for the generation and maintenance of the planet's geomagnetic field. And of course, without that geomagnetic field, there would be no life on Earth's surface.
The solidity of the inner core was proposed back in 1940 by a mineral physicist, Francis Birch. And he proposed that what Inge Lehmann discovered in 1936, so 4 years before that paper, that what she discovered is actually a transformation of a liquid to a solid phase of iron. At that time, when Inge Lehmann discovered the inner core, she didn't have sufficient information from the seismic waves that she was looking at, and those were compressional waves, to conclude that the inner core was indeed solid.
There was just a change in the waves, and that was it?
Yeah, that was the seismic waves that can tell us if there is a change in elastic properties of rocks through which they travel. So she observed that there was a significant change or substantial change in those properties, and that's how the inner core was proposed. However, Birch, as I mentioned, really hypothesized that it was a change from liquid to solid phase of iron, and then it essentially became a quest to find a mechanism or to find a proof by looking at other types of earthquake waves that the inner core is indeed solid. So the waves that I'm referring to are also known as shear waves. And as you know, after large earthquakes, there are essentially two types of ground particle motion, and one of them is known as compressional or P waves, and another is shear or S waves. So the shear waves, they cannot propagate through gas, plasma, or liquids. So if we could detect shear waves through the inner core, that would be a direct proof that the inner core is indeed solid. And so the quest for these shear waves started, I would say, back in 1940s, and it has been going on for the last 80 years or so.
And so the hunt is on to find shear waves. And what are J waves?
So J waves are essentially shear waves that propagate through the inner core.
Same thing.
So we call them J waves just to differentiate them from the so-called I waves, and I is a phase of compressional waves in the inner core. So J would be equivalent to shear waves in the inner core.
Okay.
Sure. So the J waves are shear waves in the inner core.